The previous video ended on an unsuccessful attempt to submit our solution to the Max Payrise product problem. Even worse, we don't know what is the test on which our program fails, because the system doesn't show it to us. This is actually a pretty standard situation when solving algorithmic programming assignments. In this and next few videos, you will learn how to overcome this situation and to even avoid it in the first place. I will explain to you and show you in action a powerful technique called stress testing. By the end, you will be able to implement a stress test for your solution of an algorithmic problem, use it to find a small and easy test on which your program fails, debug your program, and make sure it works correctly afterwards with high confidence. Also, you will be able to list and apply the set of standard testing techniques which should be always applied when solving algorithmic programming assignments. So, what is stress testing? In general, it is a program that generates random tests in an infinite loop, and for each test, it launches your solution on this test and an alternative solution on the same test and compares the results. This alternative solution you also have to invent and implement yourself, but it is usually easy because it can be any simple, slow, brute force solution or just any other solution that you can come up with. The only requirement is that it should be significantly different from your main solution. Then you just wait until you find a test on which your solutions differ. If one of them is correct and another is wrong, then it is guaranteed to happen, because there is some test for which your wrong solution gives wrong answer and your correct solution gives correct answer, and so they differ. If, however, both of your solutions are wrong, which also happens often, they are still almost guaranteed to have some test on which one of them gives wrong answer and another one gives correct answer, because they are probably wrong in different places. When you find a test on which your solution's answers differ, you can determine which one of them returns wrong answer and debug it, fix it, and then repeat the stress testing. Now let's look at the practical implementation. I've already implemented the stress test for this problem. It is in the file called stresstest.cpp. Let's look into that. So it is almost the same as the solution that we've sent last in the previous video, but I've added some things. First, we add this include cstdlib, and this include file just allows us to use a part of standard library to generate some random numbers, and we'll use it to generate some random tests automatically. Then we have the same code of two functions, max pairwise product and max pairwise product fast, which we used in our last solution, which we submitted in the system. But now, in the main function, we have a whole additional while loop. Here it is. And this is where the stress test itself is. So, what do we do in principle is we generate some random tests, then we launch both solutions, max pairs product and max pairwise product fast, on this random test, and we compare the results. And the idea is, if you have a correct solution and another correct solution, and the correct answer for your problem is the only correct answer, then any two correct solutions will give the same answers for any test. And if you have some wrong solution and some correct solution, then on some tests their answers will differ. And also, if you have two wrong solutions, then probably they are wrong in a different way. And then there will also be some test, hopefully, on which their answers differ. If you generate a lot of tests, then with some probability at some point you will generate a test for which the answers of the solutions differ. You can detect that situation and then look at the input test and at the answers. Then you can determine which of the algorithms was right and which was wrong. Maybe both were wrong, but anyway you will find at least one of the algorithms which are wrong, because if their answers are different, then at least one of them gives wrong answer. And then you will be able to debug that algorithm, fix the bug, and then run the stress test again, and either you will again find some difference, or you won't find any difference anymore, and then hopefully you fixed all the bugs in all the solutions, and you can submit it. So, how it works in practice? First, we need to generate the test for our problem. We start with generating number n, the number of numbers, and our solution, our problem states that n should be at least 2. So we first generate a big random number using function rand. Then we take it modulo 10, and it gives us some random number between 0 and 9, and then we add 2, and so we get a random number between 2 and 11. Why is it so small? Well, we first want both our solutions to work fast enough, and also if we create a big random test, it will be hard for us to debug it, so we start with some relatively small value of n. We immediately output it on the screen, so that if we find some test for which our solution is wrong, we immediately see it on the screen. After generating n, we should generate the array of numbers a itself. So we iterate n times, and we add random numbers from 0 to 99,999 to the end of array a. So these are the numbers in the range which is allowed. And then we also output all these numbers in one line separated by spaces and a new line character. So by this time we've already output the whole input test on the screen. Now what we need to do is actually to launch both our solutions on this input test and get two results, the results of the naive solution and the results of the fast solution. After that we compare those two results. If they are different, it means that at least one of the solutions was wrong. So we output words wrong answer on the screen, and we also output the first result, the space, and the second result, and the new line character. After that we break our loop. You can notice that our while loop is a so-called infinite loop, but we actually end it as soon as we find some test for which our solutions differ. If we don't find that they differ on some test, we just output word OK on the screen to denote that actually both solutions have already computed the answers, but the answers are the same, and then we continue. So we continue our infinite loop in the search of the test that will save us, that we can use to debug our solution. And we wrote that code just in front of all the code to read the numbers from the input, to compute the answer, and to output it to the screen. So we basically inserted this code in our regular program, but instead of reading numbers from the input, it will first try to find the test for which our two solutions differ. And in the next video, we will launch the stress test to find a test on which our solutions differ, debug our fast solution and fix it.